Hello, hi everyone. So welcome back to my channel and let's start with today's Leetcode challenge. Till now we have completed around 10 to 11 challenges. In case you have missed any, you can watch it on my YouTube channel. I've created a playlist for the same. So let's just quickly start with today's question. The kth largest sum in a binary tree. You are given a root of the binary tree and a positive integer k. The level sum is the tree, the sum of all the nodes that are on the same level, and we have to return the kth largest sum in a tree. And if there are fewer than k levels in the tree, we have to return -1. Okay. So if we see the example, we have 5, then 8 and 9, 2, 1, 3, 7, and 4, 6. So the level sum will be first is 5, then it is 17, then it is like 3, 6, and this is 13. Okay, and the last one is 10. So we have 4 levels. Okay, 1, 2, 3, 4, and this their sums are 5, 17, 13, 10. And the kth largest would be the k is second. The second largest would be 13. So you have to return 13. Okay, and in case they are not k, if k is, let's just say 5, and if the levels are only 4, so in that case we have to return -1 because it is written here. If they are fewer than k levels in a tree, we have to return -1. Okay, I think we are good on the problem statement part. So let's just move to the intuition part to make it understand more. So if you see directly, right, this is level 1, this is level 2, this is level 3, this is level 4. In trees, we generally have two ways of going to each of the nodes. First is, I think everyone is aware, DFS, and second is BFS. Okay, DFS, we go like this. First this route, then we go to the left, or either we can go to the right directly, then we go to its left, then to its left, then to its right, then its left, to its right. So we generally, this is when we go till the depth and come back. That is called DFS. And BFS is like we traverse one node and then we check for all of its children. After that, all of our children are being traversed simultaneously, then their children similarly like that. Okay, so these two are algorithms that we generally do in trees, whether it is a binary tree or binary search tree, right? So if you see this, we have to like get the level order. So how we can do? Generally for level order traversal, we use BFS. Okay, now BFS, how we will do it? First, we will traverse this node. Okay, 5. We have 5, and our first, this is our first level. Okay, so first level sum would be 5, right? And you have it stored in some storage because you need the kth largest and your k is 2. You have come to this level. Okay, this is your second level. So second level nodes are 8, 9, right? This is your second level, and second level sum is 8 plus 9, 17, right? So you store it somewhere because you need kth largest. Okay, now you don't know what is your largest at now because you are just doing traversal and you are storing your this क्या कहते हैं, sum, level order sum. Now you come to third basically. Okay, we will place it here. Now your third level is this one. So 2, 1, 3, 7. Okay, these all are at same level because the level is generally considered from their basically root of the tree, the distance of the node. So this distance is 1, 2. Okay, similarly this is 1, 2. For this also 1, 2, and for this also 1, 2. So they are all at same level. So this is called third level. And the third level sum would be 13, right? And you will store 13 somewhere in your storage. Again, when you come to fourth level, only 4 and 6 are there because there are not no any nodes in there, other children earlier we have. So 4 and 6, this is called fourth level. right? So fourth level sum would be 10. You store it here, right? Now you have your all the level sum in some storage, and you need kth largest. How you can get? You can sort it. Okay, if you sort it, it will be like 5, 10, 13, 17. Okay, you know, if this size, if this size is greater than k, that means in this you can get your kth largest, right? Second largest, if you see, second largest is this value. If you if you have k somewhere like this, fourth, fifth largest, okay, fifth largest. So now there is no value, that is because the size is already less than 5, so you cannot take it. So in that case you return -1, right? It is given in the question. But if your k is in this size, what you have to return? You have to return the kth largest, so it will be like k minus 1th value. If the k was 2, second largest, what would it be from the last second? So if you sort it reverse, you can get k minus 1, or if you want it directly, how you can get it? This will be size, let's just say n, and k is your value, so n minus k, because indexing is already 0 based. Okay, so n minus k will be, since the size is 4, you need second largest, 4 minus 2 is 2, so your second index value will be your second largest, so you can get directly n minus k. Okay, so now you can directly see which data structure you will require, because you just need to store this level sum, so you can directly use array. Okay, and after that you will sort it, and directly you can get our value with n minus k. And if this n is already smaller than k, then it will be -1. So we have all these constraints. If n is less than k, right, so that means we have to return -1. And one other data structure that we can use, okay, that will be, that we have earlier also used, priority queue. Priority queue. Okay, why I basically I'm saying this, because both, if we are using priority queue or we are using array, the time complexity will be same. I will give a small try run for the same. So we have our array will be like this: 5, 4, 6, 10, 11, 3, right? Three levels are there: 1, 2, 3 levels. Okay, okay, three levels are there. The sum is 5, the sum is 10, and the sum is 24, and your k is second largest. Okay, so if you sort it, these are already sorted, so your second largest is 10. You can directly, first you will do, store it in an array. Okay, let's just say array, and uh, then you sort, it is already sorted, so you just write the sort, and it will return you this, and your k will be array of size is n3 minus 2, that is 1, so 1. Now what is that? When you do BFS, so for time complexity, if you directly see, when we are calculating level sum, we are going to each node. That means if the size of the, if there are n nodes in this tree, so we are going all on nodes, so it will be big of n plus, since we are storing all the let's just say all the nodes values in this array, and we are sorting it, so in the worst case it will be n log n. If the tree is like this, let's just say 5, 6, 7. Okay, so for every level we are having one node with the different sum, so it will be all the nodes in this array. So the size of the array is basically n, and sorting will be n log n, right? So the time complexity is big of n plus big of n log n, and the space complexity will be big of h. H will be height of the tree, right? Similarly, when we try to use priority queue, yeah, so similarly, when we try to use priority queue, we only require this time complexity, right? Because at that moment when we are going till n nodes, we will update the priority queue accordingly for the k size, and we will get our value. And since the operations on the priority queue requires log n of time, so it will be big of n log n. So small dry run for that also will be like, now you come to this. Okay, I will also give the dry run and how we will do the BFS while doing the coding part. That will be more understanding. Let's just do the small here. So for BFS we use one queue. So for BFS we use queue, right? Because in DFS we generally don't use any data structure, but when we are using BFS we use queue. So I think in that we also have one uh, other space that will be maximum. It will contain the number of nodes at the level, at one level, and it can be for each level. For it's one, then it's two, and it maximum it can be four. So for each level it can store. So let's just say it will store n. So now here first we have our queue, so we add 6 to it. Okay, so I will make this queue here, and this is your priority queue, this is your normal queue. So 6 will be added. Now level sum will be calculated. So level sum L sum, so level sum will be now 6. Okay, and 6 will be added to this priority queue, and your k is 3, right? Now if you see 6 is done, so what will do, you will remove this and you will add their children to your queue. So now this will be removed, and its children are 4 and 2, so you will add 4, you will add 2 to it, right? Now when you calculate level sum again from 0, what you will do, you will add 4, you will add 2, it will be again 6, right? And you again add 6 to it, and whenever you add, after adding you will check if this is greater than k. If this is greater than k, then you have to remove it, right? Because at max you need only k elements so that you can get the kth largest. We will discuss it if it will be min heap or max heap later. So currently it is just a priority queue. So 4 and 2 are done. Now you will remove 4, and their children will be 1 and 9, right? 4 is removed, 1 and 9 are added. Now since 2 is also at the above level, you will remove 2 and add 3 to it, right? Now again you calculate level sum. Your level sum will be 1 plus 9 plus 3, 9, that is 13, right? Now you again add 13. You see your k is still your priority queue size is still equal to k. Now you don't have any level. Okay, now your level sum is 0, but if you add 0 to it, you need to add? I think we don't, because we don't have any current children, and the sum is also 0, we don't need to add. So we'll also check if the level sum is 0, we will not add it, right? And our k is 3. Now when you go over all this, your priority queue work is done. What you need, your third largest. So what is the third largest from this? 6. So you will return 6. Now if you want to directly access this third largest, how you should arrange these? Okay, now comes the question of which it should be min or max, right? So earlier we have seen that when we have sorted this array, which values from where we have to need our kth value from the last, because we are doing n minus k. So from last, if you see, we need k values. So if you just store these values in your priority queue, and at the top you can get this, then you can directly get your answer. And we are traversing here also from the last, so it should be of min heap type, right? So that this minimum should be at the top, and you can get your value. So think we should have a min heap. And the time complexity here also, because you are traversing all the nodes, so it is big of n. And while traversing, you are doing operations on this priority queue, and I've said the operations on priority queue are of log type, log n type. So this is will be big of n log n. And space complexity also, this will be big of n. And at max, this will be storing all the values of each level, so same big of h, right? So I think we are good on the time complexity and space complexity. Now we will move to the coding part to make this understand more. As we have discussed, we will be doing two approaches, one with priority queue and one with array. So first we just check if the root is null, because if the tree is not there, then there's no point of doing any processing. So if root is null, then we just return -1. And now we will create a storage vector, okay, array, and one is queue for doing BFS. So it will be tree node star queue, right? So it will be for breadth-first search on this tree. Now we add the root element first, and now we will go for this queue over the tree. So while queue is not empty, so this is a generic code that I will write for every type for BFS. Whenever you do BFS on tree, you generally write same code. You can use it anywhere. So first we will get the size, q dot size. Okay, now we will go while size. Okay, while size is greater than 0, what you will do? You will get first node, that is tree node, node equals to q dot front, and now you remove it, q dot pop. Now you have got your node. What you have to do? You have to add it your level sum. So we'll create a, since we need to return it in long type, so we'll use long level sum. Currently it is 0. Now we will add this level sum, the current root node value. Now we have added to it level sum. What you have to do? You have to check if node has left, then you add it in your queue. So q dot push, what you have to push? Node dot left, right? Similarly, you have to check for the right. Okay, so node dot right and add the right. Now you have added left and right. What you have to do? You have to decrease your size. Okay, so this is, you have traversed first level or second level or any level. Now what you have to do? You have to add this level sum to your array. So you have to check first if level sum is greater than 0, then you have to add it in your array. So array dot push back your level sum, right? Think we have done this processing. Now when you come out of this, you have processed all the nodes and all the level sums are added in this array. Now you just have to sort this, sort, or before it you can check directly so that sorting will not take place. If your array dot size is greater is smaller than k, that means you cannot get your kth largest, just return -1. Now you have to basically sort this array. So array dot begin and array dot end. So now you have sorted. What you have to return? Return array of array dot size minus k. This will get your answer. So we'll just try to run it. Okay, we are getting -1 using this BFS. I think BFS part is good. We are checking what is. Okay, I think, oh, we missed this. We did it wrong. If root equals to null, then we have to return -1. Okay, so there it is failing. Just try to run it. Okay, it is running fine. So let's just try to submit it. Okay, it might be due to some long values. So what we can do while adding the node value might be we can do this, convert into long first. Okay, and it is vector of int. So we have to take it long, right? I think that will be a miss. So again, we try to submit it. Yes, so it is running perfectly fine. So now what we do, we will do that priority queue operation. So this is done, right? So similarly, instead of this vector, what we will use priority queue. Okay, priority queue of long type. So priority queue long, we have to require mini. So it will be long and greater long, right? Priority queue. Now, whenever we are adding this in a priority queue, so we have to do here only. So priority queue dot push. One check, then we can get directly if priority queue dot size is greater than k. That means that we have to remove the top. So we'll remove the first because it is a min heap. So at the first it will have a minimum value and the base it will have the greatest. So I think we are good on these. Now if we don't need this check anymore, we require if priority queue dot size is equal to 0 or no, priority queue dot size is equals to k. That means that we have at least k values, so we can return the top, right? Because if in some case, let's just say this has not been taken any accounted in this loop while we are traversing and there are less 11 than k, 1 2 3 4, and the k was 6, let's just say, so it will not reach to this statement anytime, but we still have 4 sums, so we cannot directly return the top value. So what we'll do, if priority queue size this, then we have to return this. So we can directly do like this, priority queue size is k, then we return directly the top, else we will return -1. So think we are good on this. Let's just try to run it. Okay, it is running fine. So submit it. Okay, yes, it is also running similar fine. So thanks everyone for watching. In case you do like this video, please do hit that subscribe button and turn on the notifications. And if you have any questions, please do ask in the comment section. I will try to answer all of them. If you have any alternate approach, you can share in the comment section. I will review it. Thanks everyone.